All right, let's review the International System Prefixes, SI prefixes here. I am going to provide you with this table on the midterm exam, and I'm going to explain to you how to use that table. In general, you could just have that table on your phone and use it wherever you want. Now, the first things is let's get introduced to the table. We have what we call a base unit for SI measurements. Okay, base units are seconds or meters or grams, volts, hertz, etc. The other prefixes are used in mostly in engineering notations. Let me give you an example. Instead of saying 1,000 meters, for example, you're probably going to say 1 kilometer. That's pretty conventional. There might be a reason to say 1,000 meters, but most of the time you're going to see that people use the shorter version of representing any notation. All right, so how is this relation between those two converted or seen on the table? The first thing you need to notice is the kilo, which is a factor of 10 to the power of 3. All right, so and then you are going to see the base unit. The base unit is not put in this table because it is assumed that you understand the base unit and what it is. And a base unit is basically let's say the base unit factor is 10 to the power of 0, or which is also equal to 1, right? So you don't need a factor for the base unit to calculate. However, how do we go from 1,000 meters to 1 kilometer? So what we're going to do is we're going to say, okay, we have a starting point. Okay, starting point that is the base unit, meters, which has a factor of 10 to the power of 0. Then we have an end point, which is kilometers, which is kilo, has a factor of 10 to the power of 3. What we're going to do is take the difference between the two, and the difference is going to be 10 to the power of 3. What we did is we subtracted 3 and 0, and we got the answer of 3. So we're going to either multiply or we're going to divide the number we have, which is 1,000 meters, to get a kilometer. All right. So if you're going on this table, if you're going down, so if you're going down from one row to another, you're going to multiply, right? If you're going up, you're going to divide. And I'm going to present it like this. Up is division and down is multiplication. I use so as usual, I use an association for remembering this. As such, going up the stairs is harder than going down the stairs. And especially if you are in grade 4 or 5, division is harder than multiplication. There you go. That's your association. So in this case, we are going down from kilometer to meters, and we're going up from meters to kilometers. We can apply either or. So let's try the 1,000 meters going up to kilometers. Okay. What we're going to do is going up is division, right? So we take 1,000 meters, we divide it by 10 to the power of 3, which is 1,000, and we get 1 kilometer. And if we're going the other way around, if we're going from 1 kilometer to meters, okay, we are going to, because we're going down, we're going to multiply by the same factor right there. That's the factor. So we're going to do 1 kilometer multiplied by 10 to the power of 3, which is 1,000. So 1,000 meters. That's how you're going to use the table. Let's take our first example here. The first example is about 46.7 microamps going to milliamps. We're going to apply the same rule. First, find the starting point, microamps. Okay, so starting point factor is 10 to the power of -6. The end point factor is milli, which is 10 to the power of -3. And the difference between the two is 10 to the power of 3. I'm not going to use any negative or positive connotation in this. I just take the difference between the two. That's the factor I'm going to use. And I'm going to decide whether I multiply or I divide. So if I'm going up, I divide. If I'm going down, I multiply. I can see here that I'm going up on the table. If I remove these, I can see that I'm going up on the table here. So I'm going to divide. All right. What I'm going to do then, I'm going to say 46.7 microamps divided by 10 to the power of 3 is 1,000, basically. And that is going to be, how do I do this? Well, here. The easiest way to do this is you take the decimal point and you move it to the left for dividing. Every 0 you divide with is going to move the decimal point one place to the left. So 1, 2, 3 for 3 zeros. And then I'm filling the blanks. There you go. That's what you can do. And that was 0.0467 milliamps. Okay. The other way to write this down is in scientific notation. For scientific notations, you're always doing 4.67. This is the base of the scientific notation, multiplied by 10 to the power of something. Now, that power of something also can be done like this. I take the decimal point, I move it 1, 2 places to the right. If I'm moving it 2 places to the right, I say 10 to the power of -2. And that's also my milliamp. As you can see now, this is the scientific notation for it. So we did the micro to milli. And let's do our micro to amps, which is the base. So if I take that, the starting point is still 10 to the power of 6 for micro to, which is, micro, to base. And position is base unit. Base unit is 10 to the power of 0, right? So the difference between the two is 10 to the power of 6. This is what I'm going to work with. However, am I going to multiply or am I going to divide by 10 to the power of 6, which is 1,000,000? Well, I can see that I'm going up to the base unit. So going up means divide. All right. So 46.7 microamps divided by 10 to the power of 6 is 1,000,000. And I'm going to use the same technique. I'm going to take the decimal point and move it one place to the left for every 0. I have 6 zeros, so I'm going to 1, 2, 3, 4, 5, 6. And then I'm going to fill in the spaces, the blanks. 0.6. That's my number in decimal format. So my number in decimal format is going to be 0.000 and then 0.46 and then 7. This is my amps. I just converted it. And how do I convert this number to scientific notation? Again, scientific notation is always going to be 4.67. That's the quotient multiplied by 10 to the power of something. And how many spaces I'm moving this? 1, 2, 3, 4, 5. So -5. That's my scientific notation. So decimal notation form and scientific notation. That's the answer you're looking for. All right. Let's now take another example. The other example is going from meters to kilometers and then to megameters. All right. So the starting point is meters, which has a factor of 10 to the power of 0. Kilometers has factor of 10 to the power of 3. Megameters has 10 to the power of 6. As you can see, this is megameter, this is kilometer, obviously. So when I'm going between meter and kilometer, I have to use the multiplier or divider of 10 to the power of 3. Okay. And when I'm going the other way with 2 megameters, I'm going to use the 10 to the power of 6, obviously. All right. When I'm going from meters to deca to hecto to kilo to mega, I'm going up. So again, up is division, down is multiplication. So I'm going to take 825,000 meters, and I'm going to divide it by this factor, 10 to the power of 3, and that is going to give me 825 kilometers. That's my first conversion. And if I go to megameters, what I'm going to do is 825,000 meters divided by 10 to the power of 6, which is a million, and that is going to give me 0.825 mega. That's not a mega. Megameters. All right, that's the conversion. Another example is we're going from microseconds to seconds. Right, so micro right here is 10 to the power of negative 6. Seconds is 10 to the power of 0 because it's the baseline. Milli is 10 to the power of negative 3. Right, so if I'm going from microseconds to seconds, my multiplier or divider is 10 to the power of 6, actually. 6. And would I, in this case, divide or multiply? Well, if you're going from micro to seconds, you're going up to the base unit, and that means you're going to divide. So 403 microseconds divided by 10 to the power of 6 is going to be 0.000403 seconds. Okay. Now, if I want to do it in scientific notation, it's going to be 4.03 times to the power of something. And that thing we have discussed before is 1, 2, 3, 4 locations, 4 spaces. Okay, so that is still in seconds. This is their decimal format, and this is your scientific format for the same number, same conversion. Right. If I am going from microseconds to milliseconds, the difference is 3. Okay, so microseconds to milliseconds is the factor is 10 to the power of 3. Division or multiplication. Well, micro to milli is going up, so division. 403 microseconds divided by 10 to the power of 3 equals to 0.403 milliseconds. That's your conversion. Let's take one more example. Let's go from kilohertz to megahertz and then hertz. Right, so if I'm going to kilohertz is 10 to the power of 3, megahertz 10 to the power of 6, hertz is the base unit, 10 to the power of 0. Kilo to mega here is 10 to the power of 3, right? So 1.4 kilohertz, that was hertz, divided by 10 to the power. Why am I dividing? Well, because I'm going from kilo to mega, which is a ascension. I'm going up. And that is going to give me, as you remember, if I'm dividing by 3 zeros, I'm going to take this 1, 2, 3 places to the left, and I'm going to fill in the blanks like so. 0.0314 megahertz. You could write in scientific notation 3.14 times to the power of something, and that something is going to be 1, 2. So -2, that's going to still be in megahertz. So decimal and scientific, both. Right? If I'm going from kilohertz to hertz, that's a different story. So kilohertz to hertz is a factor of 3, but it's going down, right? So I can take 1.4 kilohertz and multiply it because I'm going down. Kilo to, if I'm here, kilo to baseline is down, so multiply by 1,000, which is a factor of 10 to the power of 3. That gives you 31400 hertz. Right, so this is the difference. Now let's take a different approach here. So 864 kilograms is 0.864 megagrams. If I just for a second forget about the base, and I'm going to go from megagrams to milligrams. This is an example that we haven't covered yet, and how it works is mega is 10 to the power of 6, we know that, and milli is 10 to the power of -3. Now, you can say the difference is 3, but because they are different sign, this is -3, this is +6, you should always remember that now the difference becomes 9, not 3. Okay, and if you ever forget about that, what you're going to do is you're going to say, okay, so the difference between here and here is 3, and then between here and the baseline is also 3, that's 6. And then from the baseline to milli is also 3, that's 9. All right, that's possibly something you can remember to do on the midterm exam, right? So in this case, you have a difference of 9, so that's literally 10 to the power of 9. Let's do this. 0.864, right? Megagrams, multiplied or divided to get to milli. Well, from mega to milli, you're obviously going down the scale because you're going from mega, which is bigger, to milli, which is smaller. So you're going down the scale. If you're going down the scale, that means you are multiplying by the factor to the power of 9. That's a lot of zeros, right? That's really a lot of zeros. So you could possibly write it like this. 0.864 and then move the decimal point 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the decimal point should go, and then fill in the blanks. That's what it is. Okay, so your number becomes 864 0, 0, 0, and then 0, 0, 0. That's a hell of a big number for milligrams. Or you can convert that now to scientific, which is 8.64 multiplied by 10 to the power of something. And since the decimal point is here, I'm moving the decimal point 1, 2, 3, 4, 5, 6, 7, 8. So that becomes, and because I'm moving it to the left, it becomes +8, still milligrams. And that's your scientific notation for the decimal format. I hope that's helpful.